Okay, so I guess I'm live finally. You'll notice that I have no background. That's because my regular computer that I use for this decided to stop working. So yeah, go ahead and open up the call-in line now. So yeah, I had to bring in a whole different computer, which explains why this took so long. All right, now my password manager's not working today. This evening's just been fun, you know. As if having 10 children who keep slamming the doors over and over again while I'm trying to do a live podcast isn't enough, you know? Got to add something else in there. Oh, boy. Okay. Wow, there's 45 of you here. Hey, Jessica's here. Ken's here. I thought you'd all forgotten about me. Hey, even Billy Noth is here. Wow, that is awesome. So yeah, it's very green in this room today. You're just gonna have to deal with that because I just can't get my other computer to work. I've never seen a computer just crap the bed like that before. I got ready to go and my CPU just went to 100% and just sat there. So who knows? I'm probably being hacked by Russians as we speak. But anyway, for any of you who want to call in, the call-in line is 352-280-3575. And I would love you to call in because I want to make sure that it's actually working at this point. Because at this point, I don't believe anything's working, you know? My whole life, just a big shambles. You know, none of it's been worth anything just because this one little issue has come up. That's how it goes, right? Now, if none of you do call, that's fine. I'll just talk about random things, random stories and things that I happen to come up with, but it won't be very interesting. It'll be much more interesting if you actually call. So, wait, first off, let me make sure that you can actually hear me because I'm not seeing an audio. Tell me if you can hear me or not. Somebody tell me. Okay, you can. All right, great. So the number is, again, I could have had it on the screen, but none of that's working. 352 280 3575. 352 280 3575. I'm putting it into the chat right now. And I should be able to, you know what? Let me see if I can actually get this up the way it's supposed to be working. Oh, some little known facts. Yeah. So, yes, Neil is asking for little known facts. Little known fact about me is that I'm cursed. No, little known fact about me is that I am mostly Polish and a little bit of Scottish. Oh, there we go. That worked. Okay, that's good. Actually, no, that didn't work. Hold on. And I thought that I was a little bit of American Indian, as everyone, I guess, believes that they are. But then I did one of those 23andMe things, and yeah, that didn't. It proved that I didn't have any. So it proves that my ancestors were liars, and I have that in common with some certain politicians. I won't name any names, but claiming that I have Indian ancestry. So Dave says, just nod if you can hear me. No, I can't. So are you saying, Dave, that you're currently in? Is somebody saying that they're currently hearing me on the phone? Because that would be a bad sign. That would mean that you hear me, you're on the line, and I'm not seeing you in my interface. So this is partly, I thought I had this all figured out because I actually did a live fire test on this the other day, but now. So Dave says, not if you can hear me, but obviously you can hear me. I just don't think I can hear you, and I'm not seeing anything. Let's get a recount on the DNA panel for the Indian ancestry. Yes, I would concur. All right, I've just restarted my call-in thing. So here's how this works. If you call in at the number listed, then it will give you a prompt to say your name and to say the reason you're calling. And then once that is done, then it will put you in the queue. And I should be able to talk to you. That's how that's supposed to work. So if you call the number 352-280-3575, actually, you know what? I'm going to do a test. This is going to be really good quality. I'm going to do a test on myself right now. Let's see. Oh, my brother's telling me that I'm late for my YouTube live for by like 30 minutes. So that's good. At least he's taking care of me. That's for once. 407 says, can we go over charging procedures for commercial refrigeration? We could do that. That would be a good video at some point. Certainly not good for a Ask Me Anything. So I guess in the meantime, you can go ahead and ask questions in the chat if there's any questions that you want to ask. Can you find out why the Redfish meter needs an app to test capacitors instead of just being able to give a reading on its own? It requires a lot of additional math. Oh, you mean just to test capacitors? I think you can test capacitors. You can't test them under load without the app. So the under load test has to be done with the app, but you can test them with a bench test, just like a normal thing. Let's see here. I'm going to try calling my own line just to see if it actually works. And then this will act as a demonstration of how this works. So let's see here. 352-280-3575. Let's see here. I'm going to put it on speaker so you can hear it.
Welcome to the podcast. Please tell us your name after the beep.
Bryan. This is actually software that I've made.
Thanks. We are now connecting you to the podcast.
Oh, yeah, it's working. Oh, that was obnoxious. All right, so it works. Great. So just apparently nobody wants to talk to me. Fine, no problem. If you want to know where the phone number, just look back in the chat. So I'm going to do this like a true right-wing talk radio host, and I'm just going to talk about random stuff until I trigger one of you enough to make you call. So we're going to start with. Let's see here. I'm going to look in my essential stack of stuff. Billy says I need a sexier voice. That's fair. I get that. Yeah, we do need a sexier voice. Can you lick a capacitor to test it for charge? Well, you know what? I'll give you this. This is a controversy. The controversy is that a lot of old timers talk about the joke of charging a capacitor and then tossing it to somebody. And if they catch it, then they get shocked or whatever. And so that's the reason why a lot of people will say, well, yeah, that capacitor will hit you if you don't discharge it. But have you ever noticed that capacitors actually, when you shut the system off, they really don't hold a charge? It's not like you walk up to a system, and we do the practice of taking the needle nose or the screwdriver or the 10K ohm resistor. And, of course, we all do that, right? But if you do it enough, you'll notice that they're actually not charged, even when you shut the unit off. And that's because the windings in the motor that it's connected to actually act to discharge the capacitor. So when the thing goes off, so long as there's a connection between any windings between the two legs, it's going to discharge itself. So there's your controversial tip of the day, is that the idea that discharging capacitors is super important for your safety. And I'm not telling you not to do it, but that's a little bit of a misnomer. Let's see here. I need to scroll down. This would be a lot better if I had a computer that actually worked. All right, here we go. Jessica says fair enough. She's making fun of me because I say fair enough all the time. All right, so I got Lincoln here. What's up, Lincoln? Is that actually your name? As if that is your real name. Uh-oh, I'm hearing myself through backfeed, but I'm not actually talking to you. Hello?
Is that because I'm on the line here?
Yeah, you're on the line. You're actually talking to me on the phone.
Yeah. Yeah, hey, I wanted to find out, did you start Kalos yourself?
Yeah. So story goes, started the business, 16 years ago, something like that. 16 years ago, when I was in my early 20s, with my father and with my uncle. So they're general contractors. I got the AC license, and so we decided to kind of go off on our own.
That's pretty awesome. I have a GC license and just got a mechanical license.
Oh, cool.
But I started as an HVAC engineer a long time ago.
Okay. And where's that at? Where are you located?
We just moved to Wisconsin. So I started my career in Los Angeles, where we only did AC, and now we got lots of heating to do here.
Yeah. So how has that transition been?
It's actually kind of cool because I'm doing a lot of, or at least I'm going to be doing a lot of hydronic heating, and it's not really that much different than doing chillers and hydronic cooling.
Oh yeah, I guess yeah. Good point. Have you done much of it yet? So are you working for a contractor? You started your own company?
No, I just started my own company.
Okay.
Yeah.
Okay, got it. So are you just a one-man show right now, or do you have people working with you?
Just one guy right now, and I'm kind of hoping to go with high performance building and do the HVAC and the construction.
Okay. So this is a good time to catch you then. I'm glad I'm talking to you. So you're wanting to do high performance AC and general contracting. So you're wanting to build like residential high performance homes, that sort of thing, and then do the HVAC yourself. Is that the concept?
That's exactly right. Yes.
Okay. Interesting.
We my wife and I are actually building a house, and I've designed all the building envelope and all the HVAC for it. So that'll be my first project.
Okay. All right, cool. Who do you follow on the on kind of the building performance side of things? Is there anybody you watch or read?
Yeah, there's I can't think of his name now, but there's a guy who's building a house like in Atlanta.
Okay, Corbett Lunsford.
Corbett, yeah. I actually started watching his videos about a year ago.
Okay.
And then I did just a ton of reading. So as I said, I started my career as an HVAC engineer, and then I've been doing software engineering for the last almost 20 years now. And so I had to kind of come up to speed with what's changed in the last 20 years. And there has been a lot of changes, I think much for the better.
Yeah. So one of the questions I guess I have for you, not knowing a lot about the Wisconsin market, is how are you dealing with, or how are you thinking about outdoor air and ventilation?
Well, so we're going to build have you heard of a pretty good house, which is close to a passive house, but
right.
Quite.
Yeah. Bill Spone is just, I don't know if you know Bill Spone from True Tech Tools, but I'm going to have him on the podcast next week. And that's essentially what he just built, was a pretty good house, or close to passive.
Oh, yeah. Yeah. So we're going to build a pretty good house. It should be very airtight. So we're going to have an ERV for 24/7 ventilation, and we're going to do hydronic underfloor heating in the whole house. And then for AC, we're going to do mini splits, so and then that way you can zone both the heating and the cooling in almost every room.
Cool. Sounds really good. So do you have any other questions for me on the business side? Because that sounds like that's what you originally called to ask about. And then I started interrupting you.
No, it's fine. I could talk about that all day. I was just curious, like, how did you go from, just starting out to having the big business that you do?
Yeah. So the answer to that is slowly, but then it gets fast. Like initially when you're doing it, you're just doing customer acquisition. You're doing a lot of, getting to know people in the community, basically finding whatever people need to do in order to keep food on the table. The biggest thing in business is you really want to have the first 6 months at least paid for, so that you don't need to support yourself in that first 6 months, or you need to have some really good projects that are going to be profitable, because it's really hard to be profitable early on. So we weathered the storm because we started the business in 2005, and then the crash came very shortly after, when we were still very small business. But yeah, just developing a really good niche customer base to start with, so that way you've got your bread and butter. For us, that was the short-term vacation rental industry in the Orlando market. That was when we were pretty much doing exclusively residential, with just very few light commercial customers. Once we kind of got a little bit stable, then we always knew we wanted to do more commercial work. So we branched out, got a couple customers in the commercial space. That's an expertise of ours on the construction side. And just developed out those customers. And it really is one customer at a time. That was our first tagline. was one customer at a time, and just finding a way to serve their needs, being customer first. That was actually something I just listened to a podcast. Harvard Business Review has a pretty good podcast that just talks about basic business stuff. And they had a good one recently on Jeff Bezos, the founder of Amazon. Mm-hmm. And that was kind of the way that he built Amazon too, rather than saying, rather than starting out and saying, okay, this is exactly what kind of business we're going to be. You start as one thing, and in their case, it was an online bookseller. But then you find the things that your customers need, and you provide those needs. When I first started, just similar to kind of thinking about what you were saying, when I first started, the first tool that I bought was an airflow hood. It was like a $3,000. What is that? Alnor hood, yeah, and I thought I was going to be doing air balancing all the time, because that was a felt pain that a lot of customers said, we want our house to be better balanced. But I found out very quickly that people weren't actually interested in paying for that in residential. So it was a quick lesson for me to not only confirm what customers say they want, but also kind of vet what they're willing to pay for in a particular market or in a particular customer type, because we didn't start out having a really premium customer base. We've worked towards that as we've gone, and now we do have a much more premium customer base. But I figured out pretty quick that I had to just get good at doing good old rank and file service, and that's what we did. And so, in terms of the growth side, though, which is part of what you were asking, the people side is huge. I was very lucky in that we have a lot of really hardworking family members who were happy to come work for me. I was young, they were young, and it just kind of worked out that way to build that original core team. But then I always knew that I wanted to build the company through training, which is the seed of what HVAC school became. Prior to starting my own business, I was actually a training manager for a large company. That was my job. So I really just took people who I thought were the right type of people, and then just trained them in the skills to do the job. And most of that was just on the job training early on in the business. It wasn't, they would just hop in the truck with me. We'd ride around and do service calls, and then kind of built the business that way from a people standpoint.
Oh, that's a really great idea. Yeah, I have to say your videos are, I think I have a pretty unique perspective, because I spent many years as a design engineer, but I never, aside from going out to a big job site just to look over, what they were building, I never actually charged a system or had my hands, doing any brazing or anything in the field like that.
Oh, got it. And so, in terms of your challenges, what do you think you're going to be most challenged with?
Well, I mean, what I would love to do is have a company where we built, super high performance houses for people, and we did the, both the energy design of the building itself and all the systems. But I have doubts, which you actually just kind of touched on. I have doubts if there's really a market for that. I don't know if people are willing to pay. I mean, I drive around here in Madison, Wisconsin, and man, the number of buildings that you see being built with very traditional materials is the vast majority of buildings.
Yeah. And there's a reason for that. And it's the same reason why so many products are outsourced to China for manufacturing. We can all say that we want better, but the reality is that when you have so many players down the chain, and then you have, at least to some degree, a cost-conscious consumer. Hey, that's 3 C's, cost-conscious consumer. That causes you to squeeze every part of that, and then the beginning, the design process, the products that are chosen end up getting, kind of a race to the bottom, and I think that's happened a lot in construction. One thing that I would suggest that you do, if you haven't already watched Matt Reisinger and the Build show. Okay, you're familiar with Matt. Yeah, and I think, so Austin, Texas is a good example of a market that clearly does have an appetite for premium construction. And honestly, I think the way that that's developed is mostly through FOMO, fear of missing out. So when you have some people with money, and one of them gets a house built that's with really high quality materials and is getting really good comfort results, and then they tell their friends, hey, this is what I'm getting done, then people start to fear missing out. But when the status quo is to build with poor quality materials, without a lot of design and without excellent construction, then poor outcomes become the norm and everybody just sort of accepts it. And that's, I think, what you are going to want to shift. And I think you can do that. Madison is a fairly high end market too. I mean, there are definitely people with a reasonable amount of wealth, and there's some high end segments, obviously pretty hard hit by COVID in terms of, the downtown area and all that. I was just recently in Wisconsin, and my wife's family was talking about Madison and what a ghost town it is right now. So I'm sure there are some challenges right now, but that's what I would suggest. I mean, you only need one customer to get started, and then you want to riff on that, riff on what you learn from that, and hopefully do it in such a way that you don't lose money, because early on, the tendency we all have is to knee jerk towards cheap prices. And that's something I would strongly recommend against, really understanding gross margin early on in the business, so that way you're not getting off on the wrong foot, because there's nothing more disheartening to do a bunch of work and realize that you actually got to pay money to do it rather than make money. And I've done that many, many, many times. Yeah.
Yeah. Well, thank you. After watching so many of your videos, it's nice to chat with you.
Yeah. It's been nice talking. Yeah. Thanks so much for calling in.
Yeah, my pleasure. Thanks.
All right. You see how easy that was? He just picked up the phone and he called in. I've got to get you all trained. Somebody asked me, let's see here. Let's go back to some of the questions. One of them was, if there's a business book that I recommend, definitely recommend Jim Collins' books, Good to Great and Built to Last. Those have been the most influential books on me. Obviously, books like, all of a sudden my mind's going blank here. The E-Myth Revisited is a great book, just to kind of think about building processes in businesses. But honestly, I don't know if any of those books are the most important thing to start with. I would almost just suggest having a mastery of your customers, understanding your pricing, and then providing really good service is a good place to start. And then the next step is getting people, which is what Good to Great really talks about, how to develop an organization that produces really great people and puts them in the right positions. So those are some of my suggestions. Steve.
Yes, sir. Good evening.
How are you?
I'm fabulous. How are you?
I'm excellent. It's good to hear from you. So what's going on in your world?
Talk to you now.
It has been a while. You send me a text message every now and again, and I appreciate it. I'm not very good at responding, but I do appreciate it.
Well, you're a very busy man. I understand. Well, I almost called you yesterday. I know I think you're an electrical whiz.
Okay.
And I've got one driving me nuts.
All right. Good. I like this. I like the sounds of this.
Okay. I know you don't do a whole lot of natural gas down there. Phase and polarity. I think I've seen you do a video on it a time or two.
Yep. We've done some on that. Yep.
Okay, good. We got a furnace, and it is giving us random errors on the circuit board. And we've changed circuit board. We've done everything to this thing. So they send me out there from, it's 120 volt, from L1 to L2. I'm getting 117 volts. When I go from L1 to ground, I get 122 volts. When I go from L1 to 24 volts or R, whatever you want to call it, I'm getting 72 volts.
Okay.
I should be getting 92 if I've got 117 feeding it, which was a little low.
What are you getting between ground and neutral? Did you measure between ground and neutral?
2.2. Now, what I did is I tracked the wires back. This house is an older house. It's been worked on, and they have got a plethora of wires hooked into a giant gang box that feeds, I don't know what it feeds. So, but that furnace should be on a dedicated circuit according to code. So with that polarity being 72, where in the world am I losing 20 some odd volts? I should be getting like 92 if I've got 117 and and 24 volts, whatever that math comes out to be.
Yeah, and I didn't write down all the numbers, but it sounds almost certainly like you've got some sort of additional impedance resistance in, I guess it would be in your neutral, right? Because you're reading your full applied voltage between your line and ground, right? You're reading the full applied voltage between line and ground, but not the full applied voltage between line and neutral, right?
That is correct.
Okay. Yeah. And in that case, it sounds like you've just got some impedance in neutral. So neutral is probably just poorly connected, significantly poorly connected somewhere, because you've got your full path. And just out of curiosity, so did you check back at the panel what you had between your leg and neutral, and you had the full amount there?
No, I did not. They're a COVID-19 customer, and this was down in the basement. They didn't want me. They're renovating the house anyway.
Right. Yeah, that would be the next test would be to chase it back and see where it changes. So if you've got that lower voltage and that's all I'd focus on right now, because obviously whenever you're getting a different voltage present between line and neutral and line and ground, that's either an issue with ground or neutral. But in this case, since your neutral number is the lower number, then your issue is with your neutral number. I mean, with your neutral. So that's what I would focus on, is why is your neutral have some additional impedance in it? And it's likely, I mean, it's pretty much got to be.
Wired up to it.
What's that?
They've got other circuits wired up to that furnace circuit going to, I have no idea where, other outlets in the house or something. Some handyman's been in there, and there must be 6 wires going into that one gang box.
Yeah, I mean,
so
it seems unlikely that you've actually got some sort of weird series circuit. It just seems more likely that because of that, it definitely increases the odds that you've got a poor connection, because when people wire circuits into outlets, for example, you're actually making the circuit through the neutral through the side terminals on the outlet. So it just sounds to me like somewhere in that circuit, it doesn't sound to me like, I would guarantee, I'd be willing to guarantee that somewhere in that circuit you've got a poor connection, especially since they're in the process of remodeling. Anywhere and any added resistance into the neutral circuit will result in what you're seeing, and will definitely result in problems. You can't have any imbalance in between neutral and ground on a furnace without it having some ramifications either direction, poor grounding or poor neutral. So that's strictly where I would focus. I would start all the way back at the beginning and just start at the panel and go neutral to ground, go neutral to hot, and see what you've got, and then just trace it down until all of a sudden that goes away. And I would probably use a tone generator on it. I'd probably de-energize, once I kind of found what I could find, I'd probably de-energize it, disconnect the conductors, and then use a tone generator on it and go around with a wire tracer and just try to figure out everywhere that circuit goes in the house and open every possible box and outlet or anything else that might be connected to it.
Okay, let me throw this out to you, because I'm not an electrician. I've had problems in the past on certain furnaces that don't like having a GFI circuit on it.
Yeah.
For some reason, and this furnace also has one on there.
Mm-hmm.
Well, if that isn't causing an issue as well, maybe the issue.
Is it possible? I guess, because a GFI does have a circuit board in it. And so is it possible that it could be actually adding some impedance to the circuit as well? Could be. I would definitely try swapping it out. It can't hurt. See if the issue goes away. But again, just to define what the issue is, the fact that you have an imbalance between neutral and ground, and the measurements you're getting between your line and ground line and neutral are different. You want to keep chasing it until that problem goes away. You shouldn't see any variation on those, because if you do, that means that there's something wrong in one of those circuits, and in this case, it's neutral. So I wouldn't suspect you said it's a GFI. It's a GFI breaker. Is that what it is, or is it a?
They've got a combo switch for the furnace.
Okay.
Cut off.
Okay, could be. I mean, that's just a matter of going back before that and just seeing if the problem goes away back before that. You just have to kind of walk your way through and see where you start measuring, normal, which would be 0, neutral to ground, and the same from leg to ground and leg to neutral. But yeah, could be. It is possible.
All right. I knew I should have called you yesterday.
Hey, you've got my cell phone number, so feel free.
All right. Well, thank you for taking my call, and we'll get back out there and see or I'll give the landlord a buzz and tell him to.
Yeah, I mean, it's it's a job for an electrician. I mean, it's not a job for a regular, for an AC contractor. It's something I would dive into because we've got an electrical license. But yeah, that's that's really your job kind of ends there. As soon as you have an imbalance, that's really an electrician's job at that point.
Yep.
All right, Steve. Appreciate you, brother.
All
right. Bye-bye. All right.
Good.
So now it says here that your name is Sonny. Is that right?
Yeah, man. What's up, buddy?
Hey, not much. What's going on with you?
Hey, not too bad, man. Hey, what part of Florida are you guys in?
Central Florida, Orlando market.
Oh, nice. Hey, I'm down here in Southwest Florida.
Okay.
I work with a local contractor. We're train dealers.
Okay.
And I've been with the company 20 years, and I've been getting a lot of this bacteria white. From what I researched, it's Zuglia slime. You familiar with that in your area?
Yep. Bacterial Zuglia. Yep.
And basically, this is, I just want to see if maybe we're on the same page. So I tell my customers, picture the air in your house as a pie. Your filter's only going to catch 35% of what's in the air. Say that's your particulates. Then you got your VOCs, your volatile organic compounds, and your mold and your germ spores. Well, filters alone aren't necessarily there to clean the air in the house. It's just there to keep the equipment clean, the coils free of obstructions, the blowers free of obstructions. So what we're finding is that filters, the bacteria for that Zuglia slime, the microns are so small that you would need a MERV 13 or higher to actually catch the bacteria to try to help reduce that slime. Have you heard anything of that nature?
Yeah, I mean, anything that you can capture will help. But yes, you're right. Bacteria is I'm trying to remember the size. Do you remember the size of typical bacteria as far as a micron standpoint? Because I'm not recalling it. I've got a PowerPoint slide on it.
Well, basically, I think it was the micron size. I mean, from what I'm told in researching, like if you look on your standard, say your silly Home Depot filters, they don't really go by a MERV rating, but filters that do, I think once it starts showing that it can actually start catching, bacteria, if you're all the way up to the MERV level 13,
yeah.
And so many technicians are hesitant on telling people to use that filter because they believe it's obstructed to the machine, especially if you're just only filtrating right at the machine itself instead of, multiple surface grill area.
Right.
So, I mean, that's one of our biggest problems down here. We do a fantastic job installing our train equipment and the machines are running flawless, but we got people almost on quarterly services continually complaining about this Zuglia slime. We've tried everything from throwing pocket change, zinc, new Calgon algicide tablets, everything you could think of. And now we're getting to the point where we're going to start using drain solve on just about every call that we run because this slime is running amok and causing just callbacks beyond belief, especially now with the aluminum coils.
Yeah.
I didn't know if you were experienced or knew any good products out there. I've been trying the new Viper. You familiar with that?
Yep.
I've seen Bert use it actually in his videos.
Yep.
Yeah, that's some good stuff.
Yep. The pan and drain spray. We use that. We use Hvac Plus on the coils. But yeah, the best thing that we've done in terms of reducing it is using actual, pure copper. So not zinc, not change, but actual pieces of copper pounded flat, laid in the drain pan. That's what we've seen reduce it the most. But there's no one smoking gun. In fact, we have Eric Melly, who's here in the chat, is one of our lead techs, and he's down in South Florida, and we've done it on all of our recent installs that have the aluminum coils, and it has made a difference, but it hasn't solved it completely.
I've tried everything from, well, if you think back, say, to 20 years ago when you had aluminum, copper, and steel coils, and I don't recall ever having to be out on drain lines quite as frequent as I do now.
Right.
I mean, I've cut pieces of boot clip, put galvanized steel, flattened out copper, put that in there. I went as far as taking those corrosion grenades, which are zinc anodes, and I stuck those in a pan. Dude, I would throw a $20 bill in the pan if it would work at this point.
Right. Right. Yeah. And in the case of the bacterial question, it's not a galvanic reaction thing. It's the particular ions that come off of copper, and some people will say silver. We've used like high silver brazing rod as well to try to do it. And those ions have some antibacterial properties, which is why we see the problem now with aluminum that we didn't see when there was more copper in the coils. But yeah, somebody needs to come out with, I mean, I've suggested to some people, maybe start coating drain pans in copper, something to try to solve this issue. Maybe they can come out with a spray or something that contains, because it needs to be a fairly long lasting, and it's not an algicide, right? I mean, people keep saying algicide, but this isn't algae. This is bacteria. Yeah.
Well, from my research, when I'm looking it up, I think it's Zuglia, Zooglia, Zuglia slime, if I'm not mistaken. It's usually a white, real thick, almost looks like something you can batter and fry. It's pretty bad stuff down here. I don't know how bad it is up there where you are, but down here in Southwest Florida, between, say, Charlotte County and Marco Island area, it's awful down here.
Yeah, and I think you're right. I mean, there's definitely a benefit to using better filtration, and one of the effects of when you get up above that sort of MERV 13 is generally considered to be kind of a close to a magic number in terms of where you really start to get these nanoparticles that start to get captured. And then obviously 15 and better. And then you get into the HEPA range, even better. But yeah, I mean, it's true what people say that when you put a denser filter, a filter with denser media, that it can restrict airflow, but you just have to design for it. Whether you're using 4 or 5 inch media that's oversized, or like you mentioned, whether you're doing it at multiple filter back grills, which is also a good strategy. That's Neil's favorite strategy.
Yeah, that sounds good. But I mean, when you're out doing a fantastic maintenance, you're spending, adequate time taking care of these customers, but then you get the ones that are so frustrated because it's gotten to the point where some people that were on 6-month service now has to go on a quarterly service. You got to be out there every 3 months because they're not going to properly clean their drain lines. They try to do the vinegar trick, the bleach water trick, and you don't want them putting anything that's harmful into the drain line, especially if you can get back to those new thin aluminum coils. We're just down for anything that works. So I'm just asking any of you guys out there that may have known something that I don't know that's working to just put it out there, or we're down to try anything out here. It's getting ridiculous.
Yeah. And we're in the same boat. It's not as bad. And I think it does seem to be, do the TAM air handlers, I imagine that's what you're installing, right? The trained TAM air handlers?
Well, it's not just the TAMs. So say like in new construction homes, you've got these big builders down here that purchase their own equipment. It's the Bryans, the Paynes, anything, basically all the new ones with aluminum coils. I mean, Lennox still has some of the old copper and steel coils, but a lot of manufacturers now are all straight aluminum. Your Rudes, your Carriers, your Trains, just about anything that's aluminum, it seems to be worse if it's a solid aluminum coil, from my experience.
Right.
Is what I'm seeing.
Yeah, that's what we're seeing too.
If it's vertical, horizontal, it's just, I tell people, hey, look, it's almost like herpes. There's no cure, but there's treatment options that can give you better filtration. I've been using Fresh Air UV, APCO X, ER3, just something to help, treat the other 65% of what's in the air that the filters can't, catch and treat. We're kind of hesitant on indoor air cleaning, anything that would produce any type of hydrogen peroxides or, ozone, like your old air cleaners.
Yeah.
Something like the APCO that just uses UVC light with a, a carbon cell that's more of a capture and kill, I find is not something that's going to be invasive to the homeowner. They're not going to be complaining about any odd smells. You're not really going to smell a UVC light and carbon, which is essentially charcoal. I think that's pretty safe putting in anyone's home. You're not producing any byproducts. You know what I mean?
Yeah. Yeah, I mean that's my same thinking. And I think they probably could come out with UV that really focused on the drain pan, but then you still have the potential of it building up in the line if any of it makes it through. I think one of the big solutions.
Go
ahead.
Yeah, go ahead. Sorry.
No, go ahead.
No, like those UVC, the UVC light strips made for mini splits. They're just a light strip.
Yeah.
I was thinking of lining the inside of a pan with one of those. They're meant to go inside of like a blower of a mini split.
Yeah, ductless.
I've almost been tempted to put those down into a pan because I would imagine they're probably essentially close to being waterproof. They're just a LED light strip. You know what I'm talking about?
Yeah. No, that's not a bad idea. The spectrum that those use is a different spectrum of UVC, and it's more like a purplish light. So I don't know how effective it would be on that, but yeah, it would be worth trying on a house that is known to have, has a known issue with it and just see. I mean, that's kind of, we're all just throwing stuff at the wall, just seeing if it sticks right now.
Yeah. I can tell you they make a new Calgon pan tab that's made for like a 5-ton unit. I mean, it's a lunker. It's a big one. It's about the size of a thermostat. And I've used that on a gentleman's house that every 6 months I would go to it. He had 2 units side by side. He lives down there on Fort Myers Beach. His upstairs unit, no slime. The downstairs unit looked like jellyfish living in the pan. And I started using these giant new Calgon pan tablets. I don't specifically have the model number handy, but it's quite large. It's as big as an iPhone. It's quite thick as well. And that seemed to get it. I mean, if you clean everything up really nice with a backside, maybe spray the pan down with some Viper, put a big new Calgon pan tablet in there. 6 months later, it was almost like I had just cleaned it when I came back. But as soon as the customer opted not to get the tablet, 6 months later, the slime was back. So it's your traditional little pill pan tabs just aren't cutting it anymore. We're gonna have to definitely step it up with. So I'm just trying to figure out if different sides of the world is any different. If it's just a Southwest Florida thing.
I think it's worse.
What kind of ideals are out there?
It's worse, and the further south you get, the more tropical you get, just because there's more stuff in the air, and your run times are longer. There's just a lot of factors that are kind of stacked against you in South Florida. There's more moisture, there's more stuff in the air. It's just kind of all that together would be my guess. But yeah, we're seeing it, and I know a lot of people are working on it. I've talked to a lot of different chemical manufacturers. I know a lot of people have tested it, but it's still just been one of those things that is tricky. That's
why I wanted to call into you. FSRs don't even want to talk about it.
Yeah, no, I hear you. It's definitely one of those significant issues. All right, brother. Thanks for calling in. I appreciate you.
Well, great, man. Thank you, man. Yeah, have a great night.
All right, you too. All right, we got an open line. Anybody else wants to call in, feel free. The number is in the chat, 352-280-3575. I think I'll go until 8:30, just because I started so late. So some of you have commented that why do I have a green screen behind me? It's because normally I use a different computer and that computer's not working, and I don't have the software on this one to do it, which is the reason why I was so late in the first place. And now my computer over here is complaining at me. So anyway, I've had a lot of challenges today, but it's okay. I'm not complaining. It doesn't help anyway. Let's see here. So yeah, there's a lot of, I don't throw shade on brands. And it seems like anytime you get microchannel, it seems to get a little worse. But who knows, I don't know all the factors that lead to it, but it does seem to be a bacteria, not a fungus. That seems to be the broadly held belief when the testing has been done. But who's to say? I mean, there definitely are fungi that look that same sort of way, that kind of gummy look. And, one nice thing with copper is that copper is antifungal, antiviral, and antibacterial. But you have different substances that are more difficult to kill than others, and bacteria definitely can be one of the more difficult things to deal with and kill or deactivate. If you're talking about viruses, you don't really kill them, you deactivate them. Let's see here. What else we got? Joe Shearer says that he doesn't think the LEDs would work in the drain pan. I don't know if they would or not. I don't think that they would be bothered with a little bit of moisture. I probably wouldn't stick them right down to the bottom of the drain pan. But who knows? Let's see here. We got another caller. All right, Tim, what's going on?
Hey, not a whole lot, Bryan. How you doing?
You know, if I were any better, there'd have to be 3 of me.
I hear you. I was calling in because I wanted to see what your thoughts were. I believe y'all have already installed at least one of the new 25 SEER heat pumps, or maybe the 24 SEER straight AC by Carrier Bryant.
Yeah, they're calling them Green Speed Extreme, at least on the Carrier side. I'm not sure what they're calling it on the Bryant side.
Evolution Extreme on the Bryant side.
Yeah, or Infinity. Maybe it's not Green Speed. Maybe it's just Infinity Extreme. But yeah, we've installed several of them. I've only personally been involved with one of the first ones that we did, which is the one I did the video of. And it went okay. I mean, there were some challenges with some of the software on the controller. It was throwing an error that was just an artifact. It wasn't anything real, and I don't remember what it was. It was like a heat over temperature error of some sort. And we contacted tech support, and they said, yeah, it's just a bug. We had to update the software and firmware, which is a little bit of a thing because you had to have a card with you in order to do it quickly. So there's a few little things that were a little tricky, but we haven't had any real problems with it. What have you had a chance to work with it?
I have not. I had my first chance to potentially sell one the other day. And I was really anxious because there's been a lot of hype about it. I was wondering, in your market, y'all deal with a much heavier latent load than we do. I was very curious how it performed, especially in part load conditions, if it was able to maintain comfortable conditions inside in terms of the latent load.
Yeah, it did. And in terms of both what we measured using MeasureQuick and in terms of customer feedback, but I will confess, we haven't used it, to my knowledge, in a super challenging environment. Like, we haven't used it in a house that was previously had a significant problem. So the homes we were doing it in are, pretty much standard regular homes that don't have a huge issue. While we do have a lot of latent load, we size for it. And so you don't generally run into houses that, have huge issues, but every once in a while you bump into a problem house, and we haven't had that issue. But yeah, in the measurements that I took on it, even when it was turned down, it was performing really well. And again, a big part of that is you have to match your blower turn down to your compressor turn down. You see a lot of brands that start to float up their suction saturation. They start to float up their coil temperature as the system turns down in order to squeeze a little more efficiency out of it. But that in a high latent market, that's a mistake. And another thing that I find in a high latent market is that a lot of times the design suite, your manual S, your manual J, they don't really fully deal with the realities of high latent conditions, especially in homes that aren't maybe as tight as they could be. So that's another factor. We're generally running our equipment pretty heavy on the latent side, low sensible heat ratios. And so for us, yeah, I mean, it's actually one of the stated benefits of this equipment over the prior line is that it does dehumidify better.
Nice. That's kind of what I was hoping to hear. We obviously, our market's not as latent burden as yours.
What is your market? Where are you at?
Coastal Zone 3, North Carolina.
Okay.
So it's not as bad as Central Florida, but we have our days.
Yeah.
And it's our part load conditions that are our biggest issue.
Right.
So I was kind of curious how they performed for you.
Yeah, I mean, it's still, you still want to size things properly and all that, but yeah, it does seem to be better in terms of part load. And again, we've done a lot of testing on a lot of multi-stage, multi-speed equipment, and it's very common for them to start to underperform on the latent side when they turn down. And again, I only was personally involved in one job all the way through doing all the testing and the MeasureQuick report and all that. But on that one, it did very well, even once we started turning it down. So once it approached that point.
Awesome. Well, I appreciate your time. That's all I had, Bryan.
All right, man. Thank you.
Thanks.
All right, I got Wayne on the line. What's up, Wayne?
Yeah, Bryan, how are you?
Good, good.
First off, I'd just like to say thanks for all that you guys do. I mean, it's a phenomenal resource you guys offer here. Very appreciative of it.
Well, thank you.
So the main thing that I'm calling about right now is I was hoping that maybe you could talk a little bit about efficiency. And what I mean by that is actual efficiency or effectiveness of basically the different types of refrigerants.
Okay.
And the refrigeration cycle itself, like how you actually, get a more efficient cycle, including the refrigerant and, like subcooling and stuff like that.
Oh, good. Yeah, that's a good one. I'm gonna bring Eric on too. I'm imagining this is Eric Melly. Is this you, Eric?
Maybe.
Yeah,
Allegedly.
because you said because reasons. So I don't know if you heard. Did you hear Wayne's question?
No, because I was connecting and I was watching on my phone, so I missed the last 30, 45 seconds.
Okay, well, I'll summarize. His question was about efficiency in a refrigeration circuit, and specifically what makes one refrigerant type more efficient than another refrigerant type, and what are some of the factors. Did I summarize that well, Wayne?
Yeah, absolutely. The only other thing, like I said, was even the cycle itself, as far as like subcooling and I don't know, even a TXV versus a piston and stuff like that. Got
it. Okay. So I'll take a stab at that, and then I'll see if Eric wants to take a stab as well as whatever else you want to talk about, Eric. How about that? Sound good?
Sure.
Okay.
Sounds great.
All right. So in terms of what makes a refrigerant good at refrigerating, is it needs to be in the range where you can pressurize it and depressurize it in order to change its state from liquid to vapor efficiently. So that's the reason why we don't use air as a refrigerant, or we don't use nitrogen as a refrigerant, although that would be very convenient. It wouldn't be conducive to that, because in order to get it to condense and boil, we would have to, just apply it would just be really difficult. And besides the fact that it has water vapor in it, and that would create other issues with it. So a refrigerant, we have to be able to fairly easily manipulate it, preferably without having to produce ridiculously high pressures. That's one factor. But then the next thing is what we call the latent heat of vaporization, which means how much heat is transferred when the stuff boils. Generally, you could, it's on a per pound, on a per mass basis. And so things like ammonia, for example, are incredible at that. Propane is really good. R32 is really good. They have really high latent heat of vaporization, meaning you don't have to move as much of it in order to get a lot of heat in and out of it. So that's another really big factor. And then we think about a lot of practical things like flammability and toxicity and all that sort of thing. But in an ideal world, we could use ammonia, and it would be great in terms of how much of it you would have to move in order to do the job of refrigerating. And again, from a very practical standpoint, just to kind of really break it down, what is the goal of an air conditioning or refrigeration system? The goal is to hit a fixed target temperature in the evaporator coil and be able to hold that target temperature at design load conditions. And in an air conditioner, that's pretty much about a 40-degree evaporator coil. That's ideal for most things. We want to hit about a 40-degree evaporator coil. We can float that up in some conditions in order to get more efficiency. But generally, that's what we want, because we want to get heat out of the air. And so we want a refrigerant that we can manipulate to maintain a pretty much, all the way through that evaporator coil, pretty much a fixed temperature. You're going to get a little superheat at the end. But you design the whole system around that in order to maximize that. In terms of technologies around it, pistons, TXVs, compressor types, all of that is just about being able to get that evaporator coil to that temperature and hold it there under a wide range of conditions, and without causing any damage to the system. So when you have something like a TXV, you're able to keep that evaporator coil full with boiling or evaporating refrigerant. So you're maximizing that latent heat of vaporization without running as much of a risk of damaging the compressor. With a piston, you almost have to intentionally undercharge it during high load intentionally undercharge it during low load conditions. No, opposite, during high load conditions, so that way it doesn't end up running liquid refrigerant down the suction line during low load conditions. So there's just, you have to kind of compensate for the fact that the orifice isn't smart. It doesn't do anything. It just sits there and feeds refrigerant. And then in terms of compressor technologies, it's all just about, how efficiently can you move refrigerant in terms of the wattage input. So that's my take. Eric, what would you add or subtract from that?
Well, I mean, the other purpose of an air conditioner is for us to use it to separate a customer from their money.
Okay. That is a very efficient use.
But I concur with everything Bryan says, because he's definitely a lot smarter or well versed in that area than me, because I really haven't looked into the whys and hows of why different refrigerants are used. I know that's a factor, but he definitely did a great explanation that I would not have been able to even begin to do. I would have just said pure magic and, next question.
Okay. For those who don't know you, now they're going to think that you're literally that guy, and Eric is not that guy. He's a much better technician than I am. But yeah, I mean, that's why, like, right now when we're talking about replacement refrigerants, it's such a big factor of what is the latent heat of vaporization of this refrigerant? What is the glide of the refrigerant? Now we're doing blends. And the reason we're doing this is because we're trying to keep something that's non-flammable, non-toxic, and meets the new regulatory standards relating to primarily nowadays about global warming potential, and then also the laws about ODP. So there's just all these factors. And so we're really making some exceptions. We're allowing some things to slip because we're trying to do everything at once. But like R32, this is a good example. R410A is 50% R32, 50% R125. R32 is a tremendous refrigerant. R125 is not a tremendous refrigerant, but R32 is flammable. R125 acts as a flame suppressant. So you put them together, you get 410A, you get a pretty good refrigerant that's not flammable. Well, now R410A is going to be phased out because it's high GWP, high global warming potential. So now we can go to R32, which is got lower global warming potential, great refrigerant, but it's flammable. So we got to deal with that. So that's, those are all the factors that play into refrigerants. We're trying to balance toxicity, flammability, regulation, as well as latent heat of vaporization, as well as being able to have a system that boils and condenses within a pressure range that we can easily manage with, the type of equipment that we have. I mean, as an example, CO2, good refrigerant, decent latent heat of vaporization, but it's got these really weird issues with critical point up at the top and triple point down at the bottom, which keeps this really narrow range that it can operate efficiently in, which makes it not impossible to use in air conditioning, but very challenging.
Correct me if I'm wrong, but I thought camper refrigerators were ammonia. They were absorbers, right?
Absorption refrigeration. I don't know if they still use them. I mean, it's very small charges. It's similar to like how you're using hydrocarbons, flammable refrigerants in small refrigeration. It's all about the size of the charge. But yeah, I mean, even if the ammonia leaked out of an old absorption refrigerator, there were stories about, scrappers cutting them open and getting a whiff of that stuff, and it'll knock you on your butt. It's pretty hardcore.
Interesting.
Anything else, Wayne?
So I think I followed that pretty well. So it sounds to me like the real quantifier for the efficiency comes in just how much heat does it take to change state, and if it takes a lot to change the state of this thing and it falls into all the parameters it needs to be, then that makes it a pretty good refrigerant because of that fact.
Yeah,
you don't.
That's one of the biggest factors is that latent heat of vaporization. And you can also call it latent heat of condensation because it's true on the other side too. You don't have to move a lot of it to absorb and reject a lot of heat when it's changing state. That's what makes it.
Go ahead.
No, go ahead.
I don't want to cut you off.
Yeah, the rest of it is just about moving that stuff through the circuit in such a way that it maintains a proper evaporator temperature, and any of the components that actually take electricity, your compressor, your condenser fan, your blower, all those sorts of things, are consuming as little of it as possible to do the job that they need to do. And in terms of like compressor technology, And condenser technology, a really big thing that they've done is they've started to decrease compression ratios by running cooler condensers, by having more surface area, and by running warmer evaporator coils. And the downside of that is that they don't move as much moisture out by themselves, and so then you have to do things like ramp down the blower speed in order to get the dehumidification capacity out of it. But again, from an efficiency standpoint, running the lowest possible compression ratio, highest suction, lowest head you can get away with, results in a compressor that's able to move refrigerant without having to compress it as much. And that results in better efficiencies as well in terms of just raw BTUs. But again, that's still on a bell curve, because obviously if you stop compressing enough, well, then you stop moving refrigerant too, and that results in inefficiency, a system that doesn't work. So it's all kind of, that part of it is all just about hitting that sweet spot of, moving the right amount of refrigerant that you got to move in order to keep the coil temperature what you need to keep it at. But also, can you afford to float up that coil temperature a little bit in order to drop the compression ratio and get a little more efficiency out of it?
Right. So it sounds like maybe the next thing that I would think would make a good one would be the lower pressures, because that would be easier on the compressor, which is a big consumer. So
yeah,
and that's efficient at moving heat and in a lower pressure range is something that's going to be a better refrigerant.
Yeah, compression ratio is more important than the pressure in relationship to outdoor pressures, but absolutely, you get to a certain point, CO2 being an example of this, where you have to start making stuff out of different materials, and it just gets really challenging to keep that refrigerant inside the system when your pressures get so high. So yeah, I mean, we really want to keep our head pressures in the range that we're all used to working with, because we all have tools that were designed to work with sub 500 psi head pressures, and then suction pressures that are obviously going to be well below that. So that kind of range is what we would like to see. When you start to get above that, it's not that you can't build one, you can, but it's tough on our tools. It's more likely to burst tubing. You got to start building it out of different materials. It becomes challenging.
Okay, and then so that's cool for the refrigerant part, and then looking at the actual system and the cycle part, I'm thinking of subcooling right now. Am I thinking correctly when I think that if you can get your subcooling as close to ambient, or maybe even with like a heat exchanger, maybe a little below ambient, that's a way to pick up efficiency?
It can be, yeah. I mean, and that's why, like in grocery store applications, they'll use mechanical subcoolers where you're actually refrigerating the liquid in order to drop its temperature. Again, it has to be part of the system architecture, though, because just doing things to magically drop your liquid temperature, well, what if it costs you energy to do those things that you're doing? So there's a trade-off there. But yes, you are right that getting your liquid temperature is close to outdoor ambient in a typical air-cooled condenser, that is helpful, which is why you've seen this move towards enormous condenser coils. In order to do that, that's what you do. Either you can run more air over it, which then you've got to run a bigger fan motor, which costs more, or you can just build a bigger coil. So now you have more natural heat exchange to the outdoor air, and so you're getting that liquid temperature lower. But the misconception, and a lot of people will say, is higher subcooling equals higher efficiency. It's not higher subcooling, it's lower liquid temperature. So there's a difference there, because you can get high subcooling by just charging the heck out of a system, drive your head pressure up and get 35 degrees of subcooling. Well, that's not going to lead to better efficiency,
right.
Because now your compressor's working against a greater head pressure. Now it's got a higher compression ratio. So you want to keep low head pressure and cool liquid. So I don't care if your subcooling is 2 degrees, so long as, I mean, I do care, but theoretically I don't care, because it proves that you have liquid quality. I do care because it would result in flash gas in your liquid line before it actually reached the evaporator coil, probably. But what I care about most of all is that you've got liquid and that it's as cool as you can get it. That's where you're going to get your best possible efficiency. If you're spending extra energy to try to get more subcooling, that in and of itself isn't going to help unless your system architecture is designed for it. Meaning you've engineered it as such, like they do in grocery stores, so that way you're actually getting the benefits of that colder liquid, lower temperature liquid.
It makes perfect sense.
I've seen, as an aside, older Lennox systems that called for like 2 degrees of subcooling. I've even seen some newer Ream systems, only certain tonnages that call for, I don't know if it was quite 2 degrees, but it was really low.
Yeah, I mean, again, from a theoretical standpoint, it's like saying, what's the ideal superheat? Well, the ideal superheat is 1 degree, right? The ideal superheat is 0.0000001 degrees, right. But the problem is that we don't live in an ideal world, and then factors outside of that can result in even, measurement uncertainty can result in having the flood back to the compressor, which could cause damage on the superheat side. On the subcool side, the problem with running low subcool at your condenser is that by the time it makes it through that line set to the evaporator coil, you could have flash gas. Now, if it was a package unit, or you had a really low, you knew you had a really short line set or something like that, then sure. So long as the liquid temperature is low, meaning you have a low approach number. Approach is comparing your outdoor temperature to your liquid line temperature. Your liquid line temperature should always be higher temperature than your outdoor, but only slightly above that is more efficient, all other things being the same. I mean, that's the problem. I've got to be really careful here because you can get these conditions because there's something wrong. But I'm saying if everything's working the way it's supposed to and you're running cold liquid and a low subcool, that's okay, so long as you don't have re-expansion in the liquid line that results in flash gas before it makes it to the metering device. Cool.
Great. So I know we're past 8:30. I don't want to take
no, go ahead. Time, no, it's fine.
If there's any way you could talk, you just spoke on it a little bit. If there's any way you could just expand on that a little bit, as far as how about efficiency from the superheat point of view, because I've never really thought of it from that at all.
Oh,
you were just giving me the ideal thing, which obviously doesn't work in practicality. But
right.
How does efficiency work with superheat at all, or if?
Well, it's simple.
If at all.
We don't want high superheats for efficiency. High superheat equals no bueno for efficiency. We accept it. Because in some cases, you may be picking up, and again, there's a lot of nuance here. Let's start with the fact that when I'm talking about superheat, I'm talking about evaporator superheat. I'm not talking about compressor superheat, because you can pick up heat in your suction line going to the compressor that doesn't impact the efficiency of your evaporator. Now, it's not good to pick up heat because you just have to reject it again. And it's not good for your compressor to pick up heat in the suction line. But in terms of evaporator efficiency, our goal is to have next to zero superheat leaving the evaporator coil in a perfect world. The problem is you can't do that because the way that we measure superheat, or the way that a valve measures superheat, requires you to have a minimum stable superheat for it to even measure it. For example, if I've got refrigerant boiling at 40 degrees into an evaporator coil, and it's 40 degrees coming out, I have no idea whether that's 5% liquid left, 10%, 21. I have no idea. I could be completely slugging that compressor seriously, or I could be just the very last bubble of liquid is evaporating, and now I'm in a perfect world because it's not making it to the compressor, but I can't discern it because I can't measure it. That's the whole thing with latent heat, hidden heat, is you can't measure it with a thermometer. So your TXV, generally speaking, a TXV gets unstable under about 5-6 degrees of superheat. With an EEV, you can do a little better than that, 3-4 degrees of superheat, and it tends to stay a little more stable down there. But again, that's where your sensor technology becomes important, because you have uncertainty in the measurement, and you do not want to run liquid down the suction line. It's just not designed for that, and you're going to damage your compressor. So that's the goal, is to run as low as superheat as we can from an efficiency standpoint, evaporator superheat. But we just recognize that we can't run the risk of damaging a compressor.
Now,
got it. That's
one.
Go ahead.
One aside from that, now I don't have a lot of experience in this area, but I've done a couple classes, and apparently some of the screw and centrifugal compressor chillers, they actually do run a zero superheat, and they check charge based on discharge superheat. I'm not super familiar, so somebody correct me if I'm wrong, but they are using 100% of the evaporator in that case, because the compressor doesn't care about pumping a little bit of liquid, so they get every last bit out of it.
Sure. I mean, there's other strategies you could use to ensure. I mean, even if you have an accumulator that's designed for that purpose, and you're monitoring your liquid level in your accumulator, you can run, and they don't call it an accumulator, they call it a low side float, essentially a suction receiver. You can run a flooded evaporator coil. There are designs that have a flooded evaporator coil in a typical compressor. I've got one at my school. If you look at the recent video I put up about that R123,
clear tube?
the clear tube, the clear tube system. That's got a flooded evaporator coil configuration, and they can be set up that way. It's not typical, and I'm sure, like what Eric's saying, I'm sure there are compressors that just don't care or have things built into them. That's not my expertise. But sure, I mean, ideally speaking, efficiency comes from controlling that evaporator temperature, and superheat is just extra. It's warmer than it needs to be, so we don't want superheat in our evaporator from an efficiency standpoint.
It's essentially part of your evaporator you're not using,
right? Or not using as efficiently,
Right, because you're using sensible heat transfer instead of latent heat transfer.
Right. And again, this is a big confusion, and Jim Bergman and I had this really ongoing, like, month-long argument about this. The air doesn't care why the coil is the temperature that it is, right? So we get all hung up on latent and sensible and all that. It all comes down to what is the temperature of the coil. Now, the way we get to a 40-degree evaporator coil that stays 40 degrees all throughout it is by using latent heat, right? Because that's how we can move a lot of heat with such a small coil. But how do they do it with, regular, water coils or glycol coils? You don't have any latent heat transfer in those, and you can get the same cooling capacity, right? It's just all becomes a matter of how fast are you pumping the fluid through. And yes, they won't be the same exact temperature all the way through, but we shouldn't get too hung up on why the coil maintains the temperature it needs to maintain, so long as it does. We just happen to know, in the case of a direct expansion system, that the only way for us to maintain that coil and the temperature we want is to control our superheat and can keep it as low as we can keep it, with it still being stable. Which, back to the question of why a TXV, if you've ever charged a piston system during high load conditions, you have to charge it to a higher superheat. You charge it sometimes 20, 25 degrees of superheat when you're in high load conditions. Well, how is that system operating then? It's operating with a starved evaporator coil. But you're doing that because you don't want it to overfeed once the load is decreased on the evaporator coil.
Gotcha. So that makes perfect sense for me. Now, after that point, after the evaporator superheat, looking at total superheat, from that point on, does that really affect the efficiency of the system much, or kind of keeping all the heat out of the system that you could possibly keep out while maintaining a safety measure there is the best you can do? Or
I mean,
really
because again, it's all comes down to mass. I mean, mass flow rate's such a big factor. And so if you're picking up more heat that you then have to reject, that does play into the equation. But I mean, you can solve a lot of that by just further oversizing your condenser, right? But I mean, there are practical design limitations to this as well. So, you got to kind of become an engineer to design for all this. But yes, from an overarching standpoint, keep the heat out of the refrigerant so you don't have to reject it in order to get maximum efficiency. And in the grand scheme of things, is a little bit of total superheat that's picked up in your suction line, is that the biggest factor? By far, no. But is it a factor? Sure, certainly. It has to be rejected still. So it is a factor.
Awesome.
Bryan, what do you think about insulating liquid lines in non-conditioned spaces?
I mean, sure. I mean, it's the same thing, right? I mean, you are picking up.
I've heard of the recommendation, but nobody ever really does it.
No, I mean, because in most cases it doesn't. It's all about diminishing returns, right? I mean, you can do these little things that might benefit, but is it going to pay for itself over the life of that system running? And on most systems, probably not. If you're running a liquid line through a very hot attic over an extended length, then sure, it could. It just depends on it. That's knowing your market and knowing your application more than anything else.
So I've also heard that you shouldn't be running like half-inch wall, at least in our market, like half-inch wall insulation in an attic. You should really be going 3/4 or 1 inch. But there again, it's like you see a non-insulated liquid line in a half-inch wall suction line. And then I've heard somewhere that duct losses are huge when they're in attics too. So those little things.
Right.
It would be not worth it in Florida to insulate, or would it be worth it?
I mean, duct losses. So you nailed one that's a really big factor because of the surface area. I mean, obviously you're running a fluid, air, through a much larger surface area. So it's much more likely to have heat gains, is a better way of saying it. in an unconditioned attic. So yeah, absolutely. These are all things that are worth thinking about, but it's all about knowing your market and the way that you install it. And there's probably plenty of things we could do. Now, in terms of where you would know that you had a problem is if you're running a system and you've got buildings like we work on that we did not install in multifamily with really long runs of copper, where you're seeing superheats that are 10 degrees at the evaporator coil, but then 25, 30 degrees at the compressor. Well, that's a problem. I mean, it's a problem, not so much for an efficiency standpoint, though I'm sure it matters, but it's much more about your compressor overheating. So you're going to, that compressor is going to run hot through its whole life because of that. So absolutely. But it is all application based, because even in our market, if you're running 10 feet, does it really matter that much? I mean, no. I mean, if you're not seeing a change in your suction gas temperature in between the outlet of the evaporator coil and the inlet of the compressor that you can measure, well, then no, it's not worth worrying about.
Yeah, I would say that you don't see a huge change in AC, but refrigeration, even with short line sets, you see a much bigger heat gain, even with the thicker insulation.
Well, I mean, so there's the temperature differential is a big factor there. So that grows significantly the greater the TD. So that curve goes upward really quickly. Colder suction line, more heat transfer in. What were you going to say, Wayne?
So when you talk about application based, I was going to bring up the fact that I don't know if you guys are familiar with it or not, but I'm familiar with it from the automotive world, especially in the new cars running the newer refrigerant. They run the tube-in-tube design for a heat exchanger, where they actually run the liquid line through the suction line in order to basically kind of drop the subcooling of the liquid line, and then I think just sacrifice the superheat on the suction line, but enough so that you're not going to overheat the compressor, I would assume.
Yeah, I mean, it's
per the application.
Yeah, right. It's part of the design. And so, and again, a lot of that I think comes when you really know the length. So with a typical split system, you don't know the application it's going to be installed in, so you don't have the ability to design for these things. When you have a self-contained unit or an engineered system, then you can do these little tricks to squeeze a tiny bit of extra efficiency, because you know exactly what the result will be.
Right. It also may be protecting the compressor in that instance if they're
running low evaporator
flood back a little bit with a heat exchanger.
Yep. And again, that's part of the designing. When you're weighing in a fixed amount of refrigerant and you know exactly how that thing's going to perform, well, then you're removing a lot of that variability. You could design exactly.
Awesome. I mean, you basically nailed what I was looking to learn about here.
All right. It was good talking to you, Wayne.
You'll see that on a lot of self-contained equipment. They do that.
Yeah, on like when we were talking about this just the other day, in terms of small refrigeration equipment.
Yeah, I mean, I think definitely you're making your liquid colder, but I think a lot of it is trying to protect the compressor, because they're not using pump down. In order to do that, they're not using an accumulator or a receiver, because whatever reasons. Yeah.
I'm trying to unmute. I have another caller on here, but for some reason now my software is starting to hang up on me. You're all still hearing me okay, right? You're hearing me okay, right, Eric?
Yes.
Okay. I don't know what's going on. I can't unmute him.
The first time I tried to call, it hung up on me, so I don't know.
It probably hung up on you because I kept restarting everything, because I was thinking that my software wasn't working, but it was actually just nobody was calling. So that's
It asked me to say my name, and then it hung up. I was like, okay.
It didn't like your name. I have all Eric's blocked. So did you have anything else you wanted to touch on?
Well, Corey kept saying over and over again in the chat about bulb position on expansion valves, but I think we should just ignore that question.
Yeah, well, you know why he's doing that, right?
I don't.
You don't? Okay. So here's the story. So Corey, who is a fabulous young technician, although I heard that you and him kind of got into it a little the first time when he started too. Is that true? Is there any truth to that?
I don't think so.
Oh, okay. Maybe that was just his side of the story. Anyway, so Corey, and I don't remember why this started, but he was in one of the groups. It wasn't my group. And he started talking about bulb position. No, somebody else was asking about the importance of bulb position. And Jeremy Smith came on. I don't know if you know Jeremy, right? Eric?
Maybe, maybe not. I mean,
okay, anyway. That's right. You're not on Facebook. That's right. I always forget. You're not any of that. Anyway, so I'm going to try disconnecting this other person and just see if it kicks him off. So anyway, he was answering a question about that, and Corey was making a really big deal about bulb position, and then Jeremy came in and said, basically, unless your tubing is really large, it doesn't make any difference how you position it. It's more important how you strap it and that sort of thing. And Corey started throwing install manuals at him and all this stuff. And then I started like just having fun with it because I knew Jeremy doesn't take that really well. And Jeremy is a really, really good technician. And so I started just being like, all right, watch out. Like, you may not want to do this. And Corey's like, why, you know? And so it just kept escalating until Jeremy started, you know, saying, listen here, son, and all that kind of stuff. You know, let me put you over Pappy's knee. It was this whole really funny thing. Anyway, so, and I ended up getting a little bit involved too. And then a couple years later, he came to work for us. So anyway, now he's on the team, and it was just one of those things though, because he's one of the young techs that I had a pretty heated back and forth with on Facebook, and then it ended up working out. So anyway, end of story. Corey says bulb lives matter. That's true.
The only thing I know about that I've heard about, like, really critical is if you have to install it vertically, you should have the capillary come off the top. But that's just what I've been told. Is that also something I've been led to believe that doesn't matter?
It's a good question. So the question is, which direction does the capillary come off of, top or bottom? I have seen manufacturers mount it with capillary tube down before. I think it is a Train heat pump that I've seen mounted that way, and it didn't affect it. And I'm trying to think the reason why it would matter. And I've heard people say, well, the liquid runs down in the tube and that affects it. It creates hydro lock. I don't know why that would be, but I guess I could see it. I don't fully understand that in terms of fluid dynamics. But I guess I could see, you know, the tiny tube liquid kind of getting in there, and then, but it shouldn't matter though, right? I mean, because as that bulb pressure is changing, it would still affect the liquid. So yeah,
it should still change pressure, whether it's I mean, hydro locked or not. The pressure should change, and you can push on liquid, like,
right.
And
it doesn't compress, right? It doesn't compress, really, but
it's uncompressible.
Yeah, but
so that's, maybe it doesn't. I've always been.
There has to be a reason, because
like
you
said, I haven't been super critical. Mount it to the side if you can, and move on with your life. Don't mount it where it's not touching the line, like on fittings. And
I'm much more interested in. I'm much more interested in strapping. I'm much more interested in insulating where that's applicable, things like that. So,
you know, the location is good though, because what I've seen a lot, I don't know if you've seen this, the ream units, how they don't mount it from the factory, and people love to mount it inside the unit on the top right of the coil, where it's only picking up 2 of the return lines from the coil. And I've seen that cause all kind of issues with system performance. I had a customer. They said their unit never ran right since it was installed. I moved the bulb, and it made a dramatic change in system operation without touching refrigerant charge.
In terms of moving location so that way it's getting all the refrigerant back.
All six of the return lines that come into the suction header versus only the first 2.
Right.
Or last 2, however you'd look at it.
But that's not a matter of positioning, like, 6 o'clock, 8 o'clock, 3 o'clock. It's just a matter of where it's actually positioned.
Of actually looking in the manual and saying, it's supposed to go outside the unit. Now, I know there is, like, technically a spot inside the unit where you can pick up all the bends, but that's asking people to really do too much thinking of for their own good, right?
Yeah. Too much reading.
I would just put it outside the unit.
And again, like, I'm not saying not to do what the manual says, because that's what Corey was arguing in the original battle was, I do what the manufacturer says. And of course you should do what the manufacturer says, but we all know that sometimes you get into these applications where that's not practical, or it's going to be extremely difficult to get it in that location. And so his take is that on smaller tubing, there's not going to be a significant temperature change around the tubing at any point. It's going to be the same temperature, and so why would it really matter? And I think in general with smaller tubing, that's true. Obviously, if you get to larger suction lines, then it will matter more. It'd be more likely that there would actually be a temperature gradient across it. Cool. Well, I'm trying to let other people in, but my software stopped working, so I get to work on that. But largely, once I got started, it was a success. Other than the green screen, other than the fact that I started half an hour late. Is there any other criticisms you have?
Mostly successful and mostly peaceful.
Mostly peaceful. Yeah, there was no. I was, waiting for some trolls to come on. There were some people saying that was going to happen on Instagram, but it didn't. So, I guess we're okay.
I try trolling people in the chat, but people usually just ignore me, so it's no fun.
Yeah, and what's all this you saying that I don't love you all the time? What's going on with that?
You haven't told me you love me recently. Tell me you love me and make me believe it.
Oh, that's going to be hard at a moment's notice. I mean, I love you. I love you. Really, truly, madly, deeply. I could sing. I could sing. Truly, madly, deeply. Okay. By Savage Garden, and we could see if that works, but I doubt it. So are you going to get the truck?
Please do.
Are you getting the truck?
Idea.
You don't know.
I have no idea. It doesn't matter.
Well,
not a big deal.
Okay. That was the deal, is that Eric said he wanted a truck. I have a thing against trucks. Corey said that it's stupid to get a truck. I side with Corey.
What does Corey know? He doesn't even know where to mount a bulb.
That is true. He does have a really nice truck now, though, that I gave him because I'm a super nice guy. Yeah. It looks like that.
Oh, you gave him that KUV?
Yeah. Is that causing?
Did you give him that KUV that Christian showed me the pictures of?
Yeah. Well, no, Christian took pictures of my KUV. That's mine.
So you got one too.
Yeah,
well, that's what he said. It was yours.
Yeah.
I sent back some pictures of some of the things I did. I don't know if you considered any of them, but
yeah, I haven't.
Good trucks.
I haven't really spent the time on mine that I should. Corey has spent significant time on his. He's taken it very seriously. So he says kick asparagus van right there. So he's enjoying it. But yeah, honestly, the reason I got one is strictly because I can, because I've always wanted one. I don't need one. Everyone asks me why I got one. It's like
America.
Right. It's like, why do you get all kinds of things you don't need? And for me, I'm not going to feel bad about getting a work truck. I'm not going to feel bad about that. Nobody's going to make me feel bad about getting a cool work truck. So yes, I have a cool work truck now. It's no Ferrari,
they're just jealous.
Just jelly. No, I do feel bad because there are a lot of people who would put it to better use at Kalos, but anyway, whatever. Hey,
in my KUV, I on a 1 lane each way road, I passed a guy in an Aston Martin, so you'll be proud of me. It may not be no Ferrari, but it's obviously better than an Aston Martin.
Wait, you passed a guy in an Aston Martin where?
On a 1 lane each way road where it was like a passing zone.
Oh, you passed him because you're so quick. I get it.
Yeah, that's right. Like, I mean, obviously KUV is better than the Aston Martin.
Yes.
So if there's any takeaway from this whole live chat, people need to realize that.
Yeah, indeed.
Like,
all right. Well,
all that money on that car and you get passed by a work van.
Well, yeah, but you're also 87 years old. You finally got into the places you can afford it, and now you're barely allowed to drive anymore because you can't see. Because also you live in South Florida.
We won't talk about that part.
Yeah, you live in South Florida where the average age is 83 and a half. So
110.
Yeah. All right. Hey, good talking to you, buddy. I'm gonna wrap this thing up.
All right, sounds good.
All right, enjoy the rest of your Old Forester or whatever you're drinking there.
I am drinking Buffalo Trace.
Buffalo Trace.
What are you drinking?
Fair enough. I got nothing. I mean, here, Polar.
Nothing?
Yeah, LaCroix, actually. It's not even Polar. It's LaCroix. Yeah, I got nothing. I'm a big baby nowadays. Yeah, I know.
Go to the store.
I know. Next time I'm down, don't tell the old lady. All right, buddy. See ya.
You can fit a lot of whiskey in the back of a KUV. Ask me how I know.
No, I'm not. We're not talking about. Okay, bye. Bye.
All right, bye.
See ya. Yeah, I can't hang up on anybody anymore with my software either. Okay, so I've had a difficult software day. Thank you all for joining me. We're gonna work out the bugs for next time. I'm gonna come up with a standard time of doing this. It's probably not going to be the most convenient time for everybody because when I do things at home like this is where I run into issues because my at-home gear is not as good as my at-work stuff. So yeah, we'll probably be doing it maybe in the evenings, during the work week, something like that. We'll come up with something. But it's good seeing you, and I appreciate you. And we'll see you on the next one. We'll have a fixed time. I'm going to send it on the email once I actually have the bugs worked out. I knew this might not go so well, so I didn't send it out everywhere. But I'll send it out on the email. If you're not a member of the Tech Tip list, go to hvacrschool.com and sign up there, and that'll be the place that you get notified about future live streams. All right. Thank you. Have a wonderful day. God bless you. God bless America. See you next time.